Since Bell invented the first telephone in the 19th century, voice communications have undergone several generations of development and completely changed the way people communicate. Now, voice communications network is evolving from PSTN to NGN and IMS. The voice service is also shifting from Pulse to VoIP. VoIP is voice communications over computer networks that use IP as the network layer protocol. In a VoIP call, voice signals from PSTN are converted into digital signals. Digital signals are then encoded, compressed, and processed with other digital signal processing technologies. After the processing, the digital signals and other data packets are transmitted over the TCP/IP network. At the receive end, data is decoded, decompressed, and processed with other inversive operations to yield the original real-time voice. At last, the voice is sent to the callee over PSTN. VoIP requires high real-time performance. When transmitted over the IP network, data packets are easily lost and delayed and get frequent jitters. VoIP technologies are developed to improve the quality of voice services. The DSP chips in Huawei access devices implement VoIP technologies. For example, echo cancellation and packet loss compensation. Key VoIP technologies, VAD and CNG. Call statistics show that half of the call time is taken up by silence. So, if data is transmitted through regular packets, some network bandwidths are wasted. VAD is used at the transmit end, and CNG is used at the receive end to avoid bandwidth waste. DSP determines whether an input signal is a voice or silence signal based on the semaphore at the transmit end. In the case of a voice signal, DSP packetizes it into an RTP packet and sends it to the remote end. In the case of a silent signal, DSP sends a packet with a silence tag to the remote end. The user at the receive end may think the call is ended where there is a long silence. To avoid this, DSP at the receive end generates comfort noise based on the SID during silence. Key VoIP technologies, Jitter Buffer. For RTP packets transmitted over the IP network, when they are sent from the far end to the near end, transmission disorder or uneven intervals may occur. Jitter Buffer is used to eliminate jitters. Packet delays are increased. In this way, the disordered RTP packets can be adjusted in the jitter buffer and then sent to the TDM site. Key VoIP technologies, packet loss compensation. VoIP packets are transmitted using the RTP protocol. The DSP chip checks the serial numbers of RTP packets. If RTP packets are found to be lost, voice data is automatically generated according to certain packet loss compensation methods and then sent to the TDM site. Generally, there are 3 packet loss compensation methods. These methods improve the voice quality in ascending order, consuming DSP resources in the same order. Key VoIP technologies, echo cancellation. The delay in the conventional PSTN network is small. Human voices and echoes reach the ears at most at the same time, so echoes are not perceived. However, the delay in the VoIP system is comparatively large. Echoes with a delay greater than 25 milliseconds can be perceived by human ears. When the IP phone system and the conventional PSTN are interconnected, the 2-wire, 4-wire convention is involved. If the impedance of the conversion coil cannot be completely matched, echoes occur. For echo cancellation, the auto-adaptation function is used. That is, the power of echo signals is estimated in advance. Then the estimated power is deducted from the power of the received signals. In this way, echoes can be cancelled. We will introduce many other VoIP technologies to you later.